Hello everyone, welcome to the channel. This is the second video on integration and today we'll be doing questions based on trigonometry. In the first video, we discussed that we can integrate functions like sec square x directly, whose integration is tan x, integration of cosec square x is minus cot x. We also discussed that we need to write c because it is that derivative of tan x is sec square x, derivative of tan x plus 1 is also sec square x. Any constant you take, the derivative of tan is sec square x and the derivative of c is 0. So we know integration is reverse function of derivative, so integration of sec square x will be tan x. Now, today what we are going to do is, we are going to see how to integrate cos square x. Remember, in integration, we have direct formula only for sec square x and cosec square x. Now, if we want to integrate cos square x, we have to apply the formula of cos square x, that is 1 plus cos 2x by 2. Only then we can integrate it. Direct formula for cos square x we do not have, or we cannot integrate it directly. So first apply the formula and now we can integrate. 1 by 2 is constant, so put it outside. 1 plus cos 2x dx. Integration of 1 is x and integration of cos is sin x. Now, if you see, this variable is x and here we have 2x. So, we have to differentiate 2x in the denominator. As we said, integration and derivative are inverse processes. So, when we differentiate sin 2x, now what are we going to get here? 2 upon 2. What do we get? The derivative of sin is cos, and because this is 2x and here the variable is x, we have to differentiate this 2x which will give us 2. That means integration of cos 2x is sin 2x upon 2. So in derivative, when we apply the chain rule, we differentiate as multiplication, whereas in integration, when we apply the chain rule, we write it or we differentiate it in the denominator. Now, in derivative, you can use chain rule for whatever function. Like derivative of cos of e raised to x is minus sin e raised to x, and then you differentiate e raised to x. That's fine. But in integration, the chain rule can only be applied for instead of x, you can have ax plus b, nothing more than that. So, like you can have instead of x, you can have 2x, you can have x plus 2, you can have 2x plus 1, x minus 1, whatever. Any linear forms is allowed. So we differentiated 2x in the denominator, which is 2. And that's why integration of cos square x after applying the formula will be x plus sin 2x by 2 and half this form. And obviously the integrating constant. Now let's see how to integrate sin square x. So in order to integrate sin square x, again we have to apply the formula. And that formula is 1 minus cos 2x by 2. Once again do the same, put half outside, integrate 1 minus cos 2x dx. So integration of 1 is x, integration of cos 2x is sin 2x. And as we discussed in the earlier question, because this variables are different, we have to differentiate in the denominator. So that's one difference between integration and derivative. There are many, this is one of them. That in derivative you apply the chain rule as multiplication, in integration you apply the chain rule as division. And also in integration, only what values are allowed in place of x. So the variable is x. It can be only ax plus b, not more than that. So this is how we integrate sin square x and cos square x. What we did is we applied the class 11 formulas which we know. The next one is integration of tan square x. So here also we will apply the formula, but this is from class 10, that is sec square x minus 1. Since we know the integration of sec square x, so integration of sec square x is tan x, integration of 1 is x, and the integration constant. Very simple. Just put the formula and integrate it. Integration of cot square x. Once again, formula from class 10, cosec square x minus 1 dx. Integration of cosec square x is minus cot x. Integration of 1 is x, and the integration constant. So the only thing you need to know or remember here is that we directly have the formula of sec square x dx, or integration of sec square x, that is tan x. We directly have the integration of cosec square x minus cot x. For integration of cos square x, we should first apply class 11 formula. Same for sin square x. For cos square x and sin square x, we should apply the formula of class 11. And for tan square x and cot square x, we will apply the formula from class 10. Now, if we are supposed to integrate sin cube x, we will first have to put the formula of sin cube x. Okay? So we know that sin 3x is 3 sin x minus 4 sin cube x. So from here, we have obtained the formula of sin cube x. We will write this formula here and we will integrate it. So this becomes 3 by 4, which is constant, integration of sin x, and 1 by 4 sin 3x integration. So integration of sin x is minus cos x. Integration of again sin is minus cos. But we know that it is 3x and this is x. So we differentiate 3x in the denominator. And we write the integration constant also. So this becomes minus 3 by 4 cos x plus 1 by 4 cos 3x. Derivative of 3x is 3. So simplify this and you have the answer as minus 3 by 4 cos x plus cos 3x by 12 plus c. So again, for sin cube x, you have to apply the formula. In order to integrate cos cube x, we will apply the formula. Again, we obtained it from cos 3x. So cos cube x is cos 3x plus 3 cos x by 4. So we will write this individually. Integration of cos 3x is sin 3x. Again, this is 3x and here we have x. So d by dx of 3x. Integration of cos x is sin x and plus. So the derivative will be 3. And this is what your answer is. Now remember that integration of cos x or cos 3x is positive of sin, whatever the angle, and integration of sin x or sin 3x or whatever sin value is negative. So that is one more difference between integration and derivative of cos and sin. There are so many differences we said. So integration of cos will be positive value of sin and integration of sin will be negative value of cos. So in integration, during the whole series, I will be giving some of the other hints. The hint for this video is that only sec square x and cosec square x are directly integrable functions. The rest all trigonometric functions which are raised to 2 or raised to 3 have to be integrated with some or the other formulas. If the product of two trigonometric functions, we will have to apply the formulas. So here we have sin 4x and sin 8x. To this, we can apply the formula. In order to apply this formula, we need minus 2. So what we will do is, we will divide by minus 2 and multiply by minus 2. And since minus 2 is a constant, we can write this outside. This is not what we need for the formula. So we put it outside, and now we apply the formula to this, which is cos 12x minus cos of minus 4x. Now cos is an even function. So cos of minus 4x is equal to cos 4x. Let's write cos 4x for that. And integrate this function individually. The integration is for cos sin 12x, and because once again this is 12x and this is x, we differentiate it in the denominator, and same applies for the other function. Let's see the final answer is. So integration of cos 2x, cos 4x, cos 6x we have to find here. So once again we will divide by 2 and multiply by 2. At a time we can apply the formula only for two functions. So we will take this together and leave cos 6x for the time being over there. Now the formula is 2 cos A cos B is cos A plus B plus cos A minus B. Let's put this here. So in applying the formula, we have cos 6x plus cos of minus 2x. Again, cos is even function, so this will become half integration cos 6x plus cos 2x. So cos of minus 3 is cos 3 plus 2. We will remove the negative sign. Now let's multiply cos inside. Once again, we have to apply the formula. For that, we will need 2 again. So let's multiply and divide by 2 again. So multiplying and dividing by 2, we get this. Now, the formula of 2 cos square A is 1 plus cos 2. Let's apply the formulas here. It is double diagonal, so this will become 12x. And same way, this is cos 2x plus 6x plus cos 2x minus 6x. So we are going to get minus 4x. But then, cos is even function, so now we'll write cos of 4x. We will integrate each of this. Integration of 1 is x, integration of 1 is x, cos 12x is sin 12x upon derivative of 12x, which will now give us 12. Same for the other ones. So we need to keep on applying the formulas unless and until it becomes integrate, unless and until we have separated every term. We cannot integrate cos 2x. So we need it like double and this final like cos square theta formula, or 2 cos square theta 1 plus cos 2 theta, 2 cos x cos y, otherwise 2 cos a cos b formula. Same for any product of trigonometric functions. We have 4 formulas from the previous class, that is from class 11. I will put a link up there for the formulas. You can get the formulas from there. So many questions are from the NCERT. I will put the question number and the exercise from which the questions are taken While I'm writing the next question, do hit the like button, subscribe to the channel to get the notifications. So once again, we'll have to apply the formula of minus 2 sin A sin B. We'll apply this formula for the first two terms. So we'll have to multiply divide by minus 2. So we have multiplied by minus 2. Now apply the formula. That is cos x plus 2x, add the angle and subtract the angle. Once again, we are going to get cos of minus x, but cos is even function, so we will write cos x. So the next step as basically is just to multiply both the terms with sin 3x, and once we have done that, we again know that we should be applying the formula 2 cos A sin B for both of them. Again, we need to multiply divide by 2. For the first one, because the angle is same, I'm going to apply this formula which is sin 2A. So that is going to be sine of 2 into 3 is 6x. And here, so you apply the formula, you add the angles here and subtract the angles. So this becomes minus sine 4x if you open bracket. Now sine is an odd function, so this will be plus sine 2x because the negative sign will be taken out here. So plus sine 2x and this is negative. So in effect it is minus sine 2x. Now integrate. Integration of sine 6x, this is minus cos 6x, and this is 6x, this is x. The value is different. Differentiate 6x in the denominator. Same for the others. And because the integration of sine function is negative, it's going to become plus over here. Plus over here also. And the arbitrary constant. Okay, so this is what you get. You can multiply this minus 1 by 4 in the with all the terms. So this is the integration of what kind of functions where we have product of trigonometric functions like those questions which will be sin A into cos B or cos A into sin B. As I told you, I'll put a link up there. You can just look for the form. Did you hit the bell icon? Do it right now. In the next video, we will be taking up questions from exercise 7.2. Stay safe until then.